course. Of course. Okay. Let's see here. We're just making up some fun problems today. It's gonna be fun. So we're gonna start. You guys can see the screen, right? The Zoom can see the screen.
Yes.
Everybody here, Zoom. I could be screen sharing the wrong thing. All right. Let's take the region between y equals. I really wish I'd drawn that better. Y equals x squared. Y equals x squared. And how about y equals, let's just say y equals negative x squared. And the line x equals 1. We're going to take this region right here. Everybody good with that? Everybody comfortable with that being the region that we're going to spend a little bit of time investigating that region today. Yeah, just a little. Good? Everyone good? Good. Okay. Wonderful. We're going to revolve that region around the line y equals 3. Everybody good with that? Okay. First off, is the region we are revolving around the line y equals 3 fully pushed up against the line y equals 3? No, in fact, it's not even touching it at all. Okay. So when we revolve this around y equals 3, we're going to get some like sort of weird looking bevel washer type thing. It's going to be like a, I don't even know. It's going to just look weird, right? It's like a ring with like sides that are curved and stuff, right? It looks weird. But since we're revolving around a horizontal axis, in order to get cross sections that are circular or washer cross sections, which way do we need to slice it? Right, vertically. It's always perpendicular to the axis that we're revolving around. We're going to slice vertically. If we slice it vertically, we're going to get these cross-sectional rings. That's going to be pi times the outer radius squared minus pi times the inner radius squared. Everybody in Zoom good with that?
Yes.
Wonderful. Okay. So then we have to figure out what's the outer radius and what's the inner radius. That's where things get slightly more complicated. So let's think about this here. If we want to find the outer radius, we're revolving around y equals 3. The outer radius should extend from 3 all the way down to which function? The negative x squared function, right? It should extend all the way down to the lower function. Now, previously, all the stuff we were doing was the upper function gave us our outer radius, right? Everything we've done so far was the upper function or the furthest right function gave us our outer radius. Well, now the lower function is giving us our radius because the line that we are revolving around is above the region. Okay? So what is that outer radius? That outer radius should be, well, what is this distance here from the x-axis to y equals 3? 3. Okay. 3. And then what about this little piece down here? It is x squared, right? This is negative x squared, right? But we're talking about a distance, and so the distance of that is always going to be positive. So that is it's like doing minus a negative x squared. It's like subtracting that function, but it might just be easier to write it as 3 plus x squared. And then what about the inner radius? Inner radius is going to go from here to here. Well, what is that distance? That is 3 for the whole thing that I did in green there from the x-axis to y equals 3. And how much do we have to cut off from that? We have to cut off
X squared.
squared. So this becomes 3 minus x squared. So our outer radius in this case is 3 plus x squared. Our inner radius is 3 minus x squared. Everybody okay with that? Okay. What are our limits of integration?
Uh, 0 to 1.
0 to 1. 0 because we're in the origin, 1 because we're ending at the line x equals 1. And then it should just be outer radius squared. And then inner radius squared. Subtracted, integrated, get a number. If you want to distribute all that out and solve it, you can. Let's distribute it all out. It distributes that pretty easily, actually. I was going to say we could do it on a calculator, but it distributes that pretty easily. So what do we got? We're going to have 9 plus 6x squared plus x to the fourth, and then minus 9 minus 6x squared plus x to the fourth. And so what cancels out from there? The 9 cancels out, the x to the fourth cancels out. We're just left with 6x squared minus negative 6x squared, or 12x squared. So we got pi integral 0, 1, 12x squared. Integral of 12x squared on b. That'd be over
4x cubed.
4. Right. We only got 12 up there. X cubed over 3 and 12 over 3. 0 to 1. That ought to give us 4 pi. Handwriting is good. 4 pi units cubed. That's what that says. Any questions on it? We're meeting today. Yeah. Perfect. Right when I'm getting my COVID test. It'll be awesome. I'll find a way to make it work. Yeah. Wonder if I can help. Yeah. That's gonna be fun. All right. Any questions on that? Zoom questions?
Why did we integrate from 0 to 1?
Because the region we're talking about started here where we said the intersection here, which is at 0, and then we were bounding it on the right with the line x equals 1. So left to right, 0 to 1.
Oh, okay. Yes.
Good?
Yeah, thank you.
Any other questions? Good. Zoom good?
All good?
Yes.
Good, Zoom good. Okay. We're gonna do a different function now. We're gonna do, what do we do? This will be fun. Let's do this one. Let's do y equals x squared. We're already familiar with that. And then let's do y equals sine x. Okay. And we're going to talk about this region right here. Everybody good with that? Okay. Now we're going to use this one multiple times. We're really going to investigate this this region here. So the first thing that we are going to do is we're going to do something very similar to what we just did. We're going to revolve it around a line that is above it. So let's see. Sine x only goes up to 1, right? It's the maximum. So anything above that, let's call it. Let's say we'll revolve it around the line y equals, anybody? 5. Great. Okay, y equals 5. We're all around that line. So let's set up our outer radius and our inner radius, and then we will worry about how to integrate. Okay. So our outer radius should extend from that line y equals 5 down to the lower function, because that is the one that is farther away from the line we are revolving around. Okay. So what is that? That is 5 minus the little bit that we've gone up from the x-axis, and how much have we gone up from the x-axis for that parabola? X squared. We have 5 minus x squared. Everybody good with that? Zoom good?
Yes.
Yep.
Yes.
Good Zoom. Okay. That's gonna be my new thing. Zoom good? Good Zoom. You're all gonna work. If you don't, I'm gonna force you. Okay. What about our inner radius? That should extend from y equals 5, down to the function that is closer to it, which is how far up? Sin x. So this ought to be 5, that full amount minus how much we've gone up for that function, 5 minus sin x. Any questions or issues there?
Did you just pick 5 randomly?
I mean, I picked this line randomly because Tom said, how about y equals 5?
Okay.
That's why we have 5. If we said y equals 6, then those would be 6 minus x squared and 6 minus sin x. If I said it was y equals 1,000,000, we'd have 1,000,000 minus x squared and 1,000,000 minus x. Yeah? Good?
Yeah. Okay, thank you.
Oh, wonderful. Now, this should be easy enough for us to write out the integral, right? We're going to do pi, integral. Let's see there. We're going to have outer radius squared. That'll be 5 minus x squared. We're going to subtract inner radius 5 minus sin x squared. Yeah. And where does our function or region start? 0. We know that if x is 0, y is 0. But what about the other point there? What? Where they equal each other? Exactly. So we need to figure out when does x squared equal sin x. And obviously we found one place that was 0, right? We know that it's true x equals 0. And now I know that you are all really expertly remembering Newton's method, and you could do x squared minus sin x equals 0 and solve that. Right, using Newton's method, I'm sure you all remember that perfectly, of course. But we're not going to do that. We're going to do this with a calculator. So you need your calculator. We're going to learn how to find the point of intersection of any two functions on your graphing calculator. Okay. So those of you that are at home, good Zoom, have calculator. Zoom good? Calculator?
Yes.
Yep.
Yes.
Good calculator. Good. Class good calculator? Class good calculator. Good. All right. So the first thing you're going to do is you're going to hit y equals, and you're going to graph y equals x squared. Then you're going to graph y equals sin x. Did you just say where is the y equals button? That's devastating. Good thing you're not taking the May 4th, right?
Oh, I know.
Yeah. Yeah, good thing. Whew. Yeah. All right. Everybody has graphed y equals x squared and y equals sin x. Is that true? Everybody make sure that sin x looks like sin x should look. You know what sin x should look like, right? If it doesn't look like sin x should look, then your calculator is in degrees, not radians, or you have your window set horribly. I mean, it's probably like -10 to 10 and on x and y, or something like that. Okay. Everybody have a normal looking x squared and a normal looking sin x? Zoom?
Yes.
Okay. Just make sure that you're in radians and make sure that your window isn't something ridiculous. Okay. If your window is something ridiculous, or if somehow it happens that you need to change your window ever, you can hit the zoom button, and there is one that says zoom standard. I think it's option 6, I want to say. Yeah. Just hit 6 and it will zoom you to like a regular window that you would normally look at. You can always change the window by hitting the window button and just changing the x or the y coordinates as you see fit for whatever graph you're looking at. All right. All right, so what you're going to do, you've hit y equals, you've typed in your equations, you've graphed them, you're on the graph screen. Okay, so what you need to do then is you need to hit second. Then you're going to hit trace. The trace, like the second thing on trace is like CALC, calculate. It's going to calculate things for you on the graph. There are a bunch of different options in there. The one that you want is the one that says intersect. And intersect, not intersect, but you want intersect. Everybody there? It should say first curve question mark. Zoom good?
Yep.
Okay. It should say first curve. When it says first curve question mark, make sure you are to the left, that your little cursor is to the left of where the points intersect. So you want it, obviously you want it to be the right of 0, because we know they intersect at 0, but you want to be to the left of the other intersection point. Okay? So if you're not, scroll to the left. And then hit enter. It should then say second curve question mark. Then you will scroll to the right of the intersection point, and you will hit enter again. And then it should say guess. Does that sound right? Hit enter again. And then it should give you an X and a Y coordinate at which they intersect. Yeah, the Y equals button is the one in the top left corner. So where do those intersect? 0 and I'll help people in a second. 0 and what else? 8, 7, 6, 7. Give me as many decimals on the X value as you can. 2, 6, 2. Okay. It gives you the Y value, right? The Y value, though, we don't really care about in this case because we are really only focused on X values here. So that's the X value we need. So anybody at home not get 0.876762 for your other intersection point besides 0?
Wait, you kind of cut out. Could you repeat that?
Which part?
You said anybody at Zoom, and then you just like stopped talking.
So everybody is here now. It keeps saying I'm unstable. I think it's talking about, my mental health, not the internet connection. But can you guys hear me now or no?
Yeah.
Yep.
Did you all in Zoom get 0.8767262 as the intersection point for the X value? If you did not, just let me know and I can try to help you solve your problem.
Could you go over like the trace thing?
Second, and then you're going after you graph the functions and you're on the graph screen, you're going to hit second trace, and trace is one of those top 5 buttons. I think it's the second one. Yeah, second one. Yeah, from the right. Second from the right. Second one from the right. And then in that trace window, there's like a bunch of options. You're going to choose the one that says intersect, and then it should say first curve. And then you just make sure that your cursor is to the left of the intersection point that you're looking for. And you hit enter. And then you're going to move the cursor to the right of the intersection point when it says second curve. And you're going to hit enter again once you're to the right of it. Then it will say guess, and then you will hit enter a third time. And then it should give you the X and the Y coordinate at which they intersect.
Okay, I got it. Thank you.
Wonderful. Great. Now, another option. And I want you all to do this also. Just we found that intersection point, so clear those 2 graphs off for now. And the other way you can do this is you can take x squared equals sine x. You can also write it as x squared minus sine x equals 0. And if you do that, you can graph this function x squared minus sine x and see when it has an x intercept. And so the way you do that is graph x squared minus sine x. And then you will hit second, and you will hit trace. And then you will choose intersect, not intersect, but intersect this time, because it's going to find you the x intercept. And then it will say left bound, I believe. I'll give you guys a second to get to that. Let's say left bound once you get to second trace intercept. Yeah. You can scroll down and find it, yeah. I think it's true. All right, so clear up. So did you clear off the clear out the other graphs and just leave the one graph there that you're trying to use. All right, perfect. Okay, everybody at the graph window with just x squared minus tau x there, graph? And it says left bound, question mark? Okay. Make sure you are to the left of the x-intercept that you are trying to find. So, we know that there's another x-intercept of this at 0. So make sure you're to the right of 0, but to the left of 0.8, whatever we're trying to find. Okay. And then once you're to the left of it, anywhere to the left of it, is fine. Hit enter. It will say right bound. You will scroll to the right of the x-intercept and hit enter again. It will say guess. You will hit enter again, and it will tell you that exact same value that we just found. Nice work. Yeah. You can show them at the food bank. They'll be so proud and hungry. You're like, I don't care. I just want food. All right, everybody good with that? All right, cool. So now that we've found out multiple different ways, 0.8767262 in the upper bound. I'm not going to force you to distribute all that out and integrate that and then evaluate it at that 7 decimal long thing. You're going to just use your calculator to approximate. So let's practice doing that because you need to be able to do that. People Zoom home good? Did you all find the x-intercept properly?
Yes.
Good. Now let's approximate the integral. Okay, never mind. And one thing I want to say is whenever you are working through on the calculator section and you use your calculator to approximate something like we just did to find this x-intercept, don't round that. Use the full value that your calculator gives you in this integral. And then at the end, you can round your answer to your integral to 3 or more decimals. 3 is the minimum number of decimals to round to unless they specify otherwise, round to 3. Or don't round it at all if you don't want to, you can write out the whole thing, but never round to less than 3 decimals unless they tell you to. That includes a 0. Don't put, if the answer is 7.5204 and you think, oh, 7.520, I'm just going to write 7.52. No, write 7.520. Make sure if that third one needs to be a 0, just put the 0 there. Okay. All right. So what did you guys get for that integral? Anybody? 3.9 what? 3.984 units. Other people agree with that? Yes. Lots of yeses. I like lots of yeses. Lots of yeses is good. Anybody in here in the class not get that number? And I can look at your calculator and tell you what. That's after multiplying by pi, yeah. Everybody good?
Hey, can you give a couple of seconds?
I will give you a couple of seconds. Sure.
All right, thank you.
You're welcome. I am very patient.
This is it's in math, right?
What?
To get to the oh wait, never mind. I got it.
Everybody at home get 3.984. If you didn't get 3.984 for your integral, please let me know so I can solve the issue for you so that you can get the right integrals later. You do. And we're going to talk a little more about that before, well, we'll talk about it before the May 4th test, but then I'll talk about it again before the other ones too. When are we going to? Today. This will be it. This will be all of the required curriculum. Tomorrow we're going to do one thing with volume that is not required on the test, but sometimes, yeah, I would say once every 5 to 7 years, there's a problem that you could use this other volume method for that will make it easier on the AP test, but nothing will require what we do tomorrow. It can all be done using discs and washers. Yeah. They will be free response question quizzes. Yeah, reviewing for the AP. In the style of the AP FRQ questions. Those are your only grades. Oh, I should grade your first quizzes, huh? I totally forgot about those. I graded first period and then I didn't get around to second or third period. And then I forgot about them. It's too late now. I forgot to grade your quizzes. Don't worry, I will grade them. I'm sure you all did wonderful. You are all model students and model citizens. You know. You are not a model student and model citizen, just like everybody else was. I'm sure it'll be fine. All right, everybody in Zoom is good with this? I waited because people asked you to wait. Are you all good?
Yeah.
Okay. Good question. What if I said, let's get a new custom color here. What do we like? Orange. Okay, orange. That's the orange. Okay, orange. Okay, what if I said the line instead of y equals 5 was y equals 8? How would that affect things? Would it affect the pond? Would it affect the lower limit? Would it affect the upper limit? Would it affect the inner and outer radii? Yes. How would it affect them? The only thing that would change would be 8 minus x squared and 8 minus 9. Anything that I change that to be above, if I had y equals 7,000, we'd have 7,000 minus x squared and 7,000 minus 9x. So everything else would be the same. Good? All right. What if, ooh, what a big what if here. What if, okay. What if we had the same two functions in the same region, but instead of revolving around y equals 5, we revolved around y equals negative 3. Negative 3. Same functions, sine x squared. How is that going to affect things? Is it going to affect the pi? I'm in front. Is it going to affect my limits? 0.87, 0.8767262. It will not affect the limits. Is it going to affect the variable in which I complete the problem? Is it still going to be done in terms of x? Yes. Still
Yes.
horizontal axis, right? Still slice it perpendicular vertically, which makes very thin in the x direction, makes the x. Okay. But it will affect our radii. Right now, our outer radius should go from -3 up to the upper function because that one is further away from -3. So this distance is 3, and we have to add to it the amount that this function is above the x-axis. So that would be 3 plus, which function is the upper function? Sine. Everybody Zoom good? Zoom good?
Yes.
Good.
Yep.
Good too. Okay. Fun. I like this. And our inner radius should be the distance from here to the lower function, which should be 3 units to get up to the x-axis. And how many units up above the x-axis are we? X squared. Everybody good with the inner and outer radius there? Class good? Good class. Zoom good?
Yep.
Yes.
Yes.
Good deal. Okay. So outer radius was 3 plus sine x. Squared, inner radius was 3 plus x squared. Squared. Once again, I'm not going to make you integrate that with that horrible upper limit. So you'll use your calculator and tell me what you get. hard to whistle in the math. Sometimes I just stand here and whistle. I can't whistle in the math very well. You gotta like pull it slightly away. Answer? Anybody? Anybody? Got an answer? Anybody else get that?
Yes.
2.837, yes? Yeah? 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 Lots of yeses. That's good. Class good? Good class. Zoom good?
Yes.
Yep.
Good Zoom. This is good. I'm really enjoying this now. This is going to be fun. We're going to do this every day for the rest of the year. It's going to be so great. You guys in class are going to get confused on Fridays, and I'm like, class good or Zoom good, and you're going to be like, class, no, Zoom, good, Zoom, Zoom. You're going to be very confused. It'll be okay. Any questions? Anybody having trouble getting that value? Great. What if this was y equals negative 100? No change other than the radii, right? 100 plus sine x and 100 plus x squared. Right? Good enough? We feel like we could do this if I asked you to? All right. Let's do. Okay. Get ready for the fun. Here comes the fun. Let's do. Let's do these ones. Let's do y equals x squared. And let's do y equals 2x. And I want to, let's say I want to revolve this around our region here. We'll make it green. Okay. And let's say I want to revolve this around the line. Oh, how about, does anybody got a number you like? 4. Okay, let's go with x equals. We want to go around x equals 4. Different because this time we're revolving around an axis that is vertical, which means that we have to slice it perpendicular to that. We have to slice it horizontally, which means that it is very thin in the y direction, which means we have to do everything in terms of y. Way down here at the end, dy. Okay, great. We're going to have a pi. Integral. Outer radius squared minus inner radius squared. Dy. Integrated from bottom to top. Not left to right, because we're doing in terms of y. Bottom to top. Bottom to top. Zoom good?
Yes.
Good.
Good. Class good? Good class. Okay. What's the bottom? 0. What's the top of this region? Where they intersect, the y value of where they intersect. So when there's x squared equals 2x. Well, that's just a simple quadratic, right? I don't know why I put a parenthesis there. That's weird. X times x minus 2, they intersect when x equals 0 and x equals 2. But those are x values. We want y values. So 0 squared, that's the 0. 2 squared, that'd be x equals 2, we'll say y equals 4, x equals 0, y equals. Everybody good? Everybody good, Zoom?
Good.
Yes.
Good, good. Okay. All right. Well, what's my outer radius? It is 4 units from here to here. But this is the radius. I need to cut off this little piece right here. What is this little piece right here? It's just a distance from the y-axis to a function, right? It is an x, but an x that is from which function? From the 2x function. So I'm going to just do this. We'll call that x sub 1, and that's x sub 1. Okay? You don't have to do that, but I just want to delineate between the, differentiate between, delineate, that works too, between the different x's. Okay? So this is the x from y equals 2x. And so our radius, outer radius, ought to be 4 minus x sub 1. Can I use x sub 1? Why can't I use x sub 1, Tom? Has to be in terms of y. So x sub 1 equals y over 2. Okay. So this will be 4 minus y over 2 for our outer radius. Everybody in class good? Good class?
Good class. Good soup.
Class good? Good class. There we go. Class good? Good class. Zoom good?
Yeah.
Good Zoom. Okay. So we've got our outer radius 4 minus y over 2 squared minus our inner radius. Let's find that. Our inner radius, well, this is still 4 units, but this time the amount that we cut off is, we'll call that x sub 2. That comes from y equals x sub 2 squared. Well, that radius, the inner radius, ought to be 4 minus x sub 2, which ought to be 4 minus, well, what does x sub 2 equal? Root y, exactly. 4 minus root y. Good? That's good? Good. Zoom good?
Yes.
Yes.
Good. Zoom. 4 minus root y squared. And I trust that you could all distribute and do all that unpleasant arithmetic and get an exact answer if you needed to. But let's just approximate it just for the sake of time here today. And it is entirely possible that you might have to. That's about as difficult of an integral as you might see in the free response on an area volume question on the AP test. In terms of a non-calculator, it's possible that they might make you evaluate that, but it is unlikely that they would. If it was on the non-calculator, they'd probably just say set up the integral and don't evaluate it, and you just leave your answer like that. Because on the calculator section, the chances are they would want you to just approximate it on the calculator. But it is slim chance, but a chance that they would ask you to distribute all that out in the number. You okay there, Tom? Is it having some trouble? 25 point what? 133? Lots of people got that? Zoom, 25.133?
Yep.
Good Zoom. The integral is just 8. The final answer is 8. Yeah, I mean, it's not, it's just a pain to do because you end up with, I mean, the 16s are going to cancel when you square the 4 minus the y over 2 and the 4 minus the root y. But you are going to end up with like a minus 2y and a y squared over 4 and a 2 root y, or like an 8 root y and then another y. It's a mess, but it's not that bad. Everybody good? You okay, Melanie? Uh-oh. Does it have the red rectangle of death? Does it have the red rectangle of death? Get it out of here. You should put batteries in it. You should charge it, especially the day before the AP test. All right. What if everybody in Zoom is good?
Yep.
Yes.
Wonderful. Good too. What if I said instead, let's take this region, same region, where we have x squared and 2x, right? That we just did. Same two functions, 2x, x squared, same region. Those intersect at 0, 0 still. Pretend the line went right. Okay. And what if we, instead of revolving it around x equals 4, is that what we just did a second ago? Let's revolve it around x equals -2. How is that going to change things? Is the pi going to change? No. Is the lower limit going to change? No. Is the upper limit, which was 4, right, going to change? No. Is the radii, or are the radii going to change? Yeah. What is our outer radius going to be? Should be the distance from here to the furthest away function. That should be 2 plus the x value from x squared, which was, what was the x value from x squared? Square root 1. So it should be 2 plus square root 1. Everybody good with that? Okay. And what should the inner radius be? 2 plus y over 2, remembering that this is x equals y over 2, and there's our inner radius. So the furthest right function minus the furthest left function. Okay. So nothing else changes. 2 plus root y squared minus 2 plus y over 2 squared dy. Once again, we could do that by hand, but it's just a little unpleasant. So why don't you tell me what that comes out to be? Now an answer? What'd you get? Same thing again? Fancy. Picked a good number. It's the same. Is that what you got? I know everything. Pretty cool, huh? Everybody good? Zoom good?
Yes.
Zoom good? Good Zoom. Class good? Good class. Okay. How we feel about this? Feel like we could set these up? Okay. All right, here's what we got 15, 20 minutes left here. You guys want to practice one more? Think it'd be good to practice one more? Yeah. All right, let's do one more. This is going to be fun. I'm not going to ask you to evaluate any of these. I just want you to set them up. So we're going to take a look at the function about the function 2 minus x squared I don't like that function. Change my mind. Don't worry, we're not going to really change. Let's make it 4 minus x. No, I don't like that one either. You guys enjoying this? Let me go back to 2 minus x squared. You guys good with that one? Yeah. Okay. 2 minus x squared, y equals x. And we'll also bound it by the y-axis. So we're going to bound this region by all three of these things. No, I don't want to do that. No, that's fine. Let's do that. Okay, great. We'll bound it there. First off, we're going to bound it there. We're going to take the green region, this green region that I brought here. So we're going to revolve the green region around the line, around the green line. Green region around green line. You got this? Okay. Y equals -2 and y equals 6. Just set it up. Okay. Then I want you to take, we're going to use the x-axis here also. Down this blue region. We're going to take the blue region. We're going to revolve the blue region around the lines x equals -1 and x equals 10. So you need to set up 4 integrals for me. Revolving the green region around the green lines and revolving the blue region around the blue lines. Everybody good with that? Zoom good?
Yes.
And zoom. All right. I'll give you guys 5 or 6 minutes to work through that maybe? That sound about right? All right. So I can pause the recording. We'll pause the recording. There. And so the green one for y equals 6. Right. First off, we need to find our points of intersection. Right, so we know we're going from 0 to where we're going to intersect. 1. Right, this is the point 1, 1. So for y equals 6, we should have had pi times an integral from 0 to 1 of your outer radius squared. So that should be 6 minus x squared, and then minus 6 minus, well, the other one, 2 minus x squared. Everybody agree with that for y equals 6? Zoom, you guys agree?
Yes.
Yes.
Any questions on that? Zoom, questions? No? Okay. All right, and then for y equals -2, we should have had the same thing, essentially. Pi integral 0 to 1. Outer radius now, though, should have been 2 plus 2 minus x squared. So you might have written 4 minus x squared, or you might have written 2 plus 2 minus x squared. Either one's fine. And then minus 2 plus x. Everybody good with that for y equals -2? Any questions here, class? No questions here, class? Zoom questions? On that one, good with that one?
Yeah.
Okay. All right, for the blue ones, we got our intersection point. Still going to be an integral from 0 to 1, right? Immediately, the lowest to highest is still 0 to 1. And let's do x equals -1 first. For x equals -1, it should be pi times an integral from 0 to 1. And then our outer radius should have been 1 plus this x value. What was this x value? X equals, should have been the square root of y minus 2. That's not right to everybody? And it equals y and subtract this here. Yeah. Yeah? Equals y squared. Should be 2 minus y. Yeah, whoever said y minus 2, that's not right. That should be 2 minus y. Yeah? And this one just x is y, so that one's going to be easy. So this should have been outer radius with the 1 plus root 2 minus y squared. And then the inner radius should just be 1 minus, or sorry, 1 plus the other x value here, which is just 1. So 1 plus 1. And what about for x equals 10? pi integral 0, 1. Outer limit should be 10 minus that x, which is y. And then minus 10 minus this x, which is still root 2 minus 1. Everybody good with all 4 of those? Zoom, good with all 4 of those? Any questions on those?
All good.
All good. All right.
On the quiz,
What-
will there be a mix of these calculator ones and some that we have to show our work on?
Yes.
Thank you.
All right. So